This is a video on line integrals. The question states, evaluate the line integral over the curve C of 2x plus yz ds, where C is the line segment from the point 2, 1, negative 3 to the point 0, 1, negative 1. So we start by parameterizing this line segment. And if you recall, to parameterize a line segment, the easiest way is we start with the point and turn it into a vector, and we get 2, 1, negative 3. And then we add the displacement vector times t. The displacement vector is 0 minus 2, 1 minus 1, negative 1 minus negative 3. And then we have times t. So let's simplify this. We get 2 plus negative 2t. We get 1 plus 1 minus 1 is 0, so 0t, or that's just 1. And we get negative 3 plus negative 1 minus negative 3 is 2, so that's negative 3 plus 2t. So there's the parameterized curve. And recall that when we parameterize in this way, t goes from 0 to 1. And that's because when t equals 0, the second part goes away, and we're at the initial point like we want to be. And when t equals 1, then we are adding these two vectors. But notice that the second vector is found by taking the second point and subtracting the first point. So if you take the first point plus the second point minus the first point, you get the second point. So at t equals 1, we're at the point 0, 1, negative 1, where we want to be. So now let's find ds. ds is equal to the magnitude of r prime of t dt. And r prime of t, we just take a derivative, which happens to be negative 2, 0, 2, which, by the way, is the displacement vector. It's this piece. Take the magnitude dt, and the magnitude of negative 2, 0, 2 is negative 2 squared is 4, plus 0 plus 2 squared is 4. 4 plus 4 is 8. We get the square root of 8. And the square root of 8 is the same as 2 times the square root of 2, and that's times dt. So now we can put all of this together and write down what our line integral is. And we get the integral. T goes from 0 to 1, so the integral goes from 0 to 1, of 2x. X was 2 minus 2t, so we have 2 times 2 minus 2t, plus y. Y was 1, so I put a 1, times z. Z is negative 3 plus 2t, so there's my negative 3 plus 2t, times ds, and ds was 2 root 2 dt. So here's the 2 root 2 dt. So now I simplify this. We get 2 times 2 is 4, plus 1 times negative 3. 4 minus 3 is 1. So I have the integral from 0 to 1 of 1. And then we have 2 times negative 2t is negative 4t, plus 1 times 2t. Negative 4t plus 2t is minus 2t. So I get the integral from 0 to 1 of 1 minus 2t, and I take the 2 root 2 and bring it outside, times dt. So now I integrate. This is a simple integral. The integral of 1 is t, and the integral of 2t is t squared. So I get my 2 root 2 times t minus t squared from 0 to 1. So now let's plug in. If I plug in 1, I get 1 minus 1 squared. That's 0. And 0 squared is also 0. So 0 minus 0 is 0. So this whole integral is 0. So I can conclude that the line integral over the curve C of 2x plus yz ds is equal to 0. And I'm done with the problem.